Hello, my name is Leung Jia-chun. So this video is a demonstration for my FYP2 project, blockchain-based circular economy platform for e-waste tracking. So the project is designed to improve the e-waste traceability, custody tracking, auditability, and trust between the stakeholders such as the producer, collection center, recycler, and auditor. So the system uses Hyperledger Fabric as the permission blockchain, Node.js backend API, React dashboard, and PostgreSQL centralized baseline for comparison. So in this demonstration, I will show the system architecture and software environment, blockchain network connectivity, device registration, custody transfer. So the project ran on a local development machine using Linux Mint, and the system required a multi-core computer with enough memory to run several Docker containers. No dedicated GPUs is required because this is a blockchain weight and database prototype. So the main software components are Docker, Docker Compose, Node.js, npm, Python, Progress SQL, Hyperledger Fabric 2.4.9, Fabric CA 1.5.5, React, and Express.js. So the project is organized into separate parts for blockchain checkout, API service, front-end dashboard, PostgreSQL baseline, Docker employment, test, performance, script, test, performance scripts, security scripts, documentation, and also demo walkthrough. And now I will show the version of what I'm using. So you can see here the Docker version is 28.5.2 and the Node version is 18.20.8, npm version is 10.8.2, and for the Python is 3.12.3. So now I will try to run the Fabric blockchain network. So now I will show the three main application service. The blockchain API runs on port 3000 and the baseline API run on the port 3002, and the React dashboard run on the port 3001. So this will be what being looking for my API running. And this is what it will be looking for my baseline. And also for my front end. So after I running my front end, so the dashboard now display the blockchain system source, analytics card, the registration form, registered device table, life cycle flow, provenance history, and baseline comparison features. So after running the three main application service, we will need to we will have a check for it. So here we show that the status is okay. And for the next, for the 3002, okay. So the status is also okay here. So the first business process is device registration in a real-world device lifecycle. The producer registers a device when it enters the tracking system. So the device is assigned with a digital twins using the device ID and the NFC tag ID. So I will register a Malaysia focused EVAS device. The device includes the categories: manufacturer, model, serial number, weight, production date, NFC tag ID, hazardous materials, and compliance region. So when the form is submitted, the front end send a request to the blockchain API, and the API invoke the create device function in the Fabric chain code. This is some of the device ID I have looking for. So next I will just click on the register device, and here is up. So as you can see that the message submitting Fabric transaction, and the function name is the create device, and the organization is the one NSPA. Also for the app user, organization 1. So for the message is the API request complete, and the status code should be 201, which means it confirmed that the device has committed to blockchain ledger, and the device now appear in the dashboard and become the available for custody transfer and audit history. So for my second process is the custody transfer. The life cycle start with ORG1 MSP as the producer. So the first valid transfer is from ORG1 MSP to ORG2 MSP. So which represent the collection center. So the chain code check that only the current owner can transfer the device. And I will now transfer the registered device from the producer to collector. After the transfer, the owner changed to ORG2 MSP, and the status changed to in collection. So for here, if we transfer it, so after we click on the transfer, and we'll see that the status is in the collection, and the owner will be the Klang Valley collection instead of the Malaysia producer. And for the API here, so the message will be submitting Fabric transaction, and the function name will be the transfer device. The message here will be API request complete, and the status code should be 200. So which means that the successful response confirmed that the chain code accepted the transfer. So this also demonstrates smart contract enforcement, because an organization cannot transfer a device unless it is the current owner. And if we here click again the transfer, the device is currently owned by ORG2 MSP, and use ORG2 MSP credential for the next transfer. And the provenance history here will show that the device we just collect and we created it and we transfer to the ORG2 MSP. So the project also includes the centralized PostgreSQL baseline system. So this is used for the comparison against the blockchain system, and the baseline represents a traditional centralized database approach, while the blockchain system provides a stronger temper, evidence, and shared trust between the organization. So the baseline API runs separate on the port 3002 and use PostgreSQL tables for device, transaction, and users. So we can here switch to the baseline. So for the baseline here, we can just register a new device, and from here we can just transfer it, and so the status will go to the in collection, and the owner will go to the claim query. But now this is the project for the organization 2, but we currently in the organization 1, but we can still click on the transfer, and the status goes to the in recycling, and the owner changed to the Penang certified cycling facility. And this is for the job for the organization 3, but we are in the organization 1, but we can still click on the recycle, and the status will become the recycle, and the owner will become the Penang certified. So this is just a differentiate between the blockchain and also for the baseline part. So that's all from my FYP2 demonstration. Thank you for watching.